forward. If you are ever given, let's start here, two angles and one side, you can always use the law of sines. Think about why, because can't we always find the third angle if we're given two angles? And then we have enough information to set up the law of sines. So this would obviously be 50 degrees. So then from here, I won't go through and solve it completely, but let's set up at least a true statement. So we're missing a side length, so I'd put side lengths on top. So x over sine of the angle across from that side, so it must be sine of 30, is equal to, and then the only other side we're given is 30, so 30 over sine of the angle across from that, which is 100. So now our algebra says that x is going to be timesing up by sine of 30, so then x is going to be 30 sine of 30 divided by sine of 100, right? And then that would give you the side length x. Okay. Alright, so if you're ever given this situation, you guys, there's only ever one triangle that exists. You don't have to check for multiple triangles. The only time you have to check for multiple triangles is in this one and only one situation. If you're given one angle and two sides, where a side is across from the given angle, we have to check if that triangle exists at all. There's always people on the exam that solve a triangle that is no triangle exists. Because if we're putting a bunch of different examples, don't you think we're going to have a few different types of this? Yes. There's going to be probably one where a triangle doesn't exist. There's probably going to be one where one triangle exists. There's probably going to be one where two triangles exist. Now what I do is I redraw this because it's easier for me to think of this as a swinging side like this, just because I visualized it like this. So I'm going to put my angle right here, not drawn to scale, obviously. The side across from that would be 20, so my swinging side is 20, everybody, right? Then the other side I always put right here. So 15 was my other side. Now, based on this information, everyone, isn't 20, this side 20, if I was to swing this around here, isn't it much longer than 15? It's going to swing past this. So if you think about it, isn't it going to swing and touch one time? So this only has one triangle. So now I could go back to my picture and say, okay, so it's not a deceiving picture after all. It is creating just one triangle. Does that make sense, everyone? Okay, cool. So then from there, let's just at least set up a true statement. So you'd say sine of angle x. Make sure you don't mess up, the angles are in here, obviously. Sine of angle x over the side across from it is equal to sine of angle 110 divided by the side across from that. So now my algebra would say to times up by 15 first, and then do what? Do the sine inverse. So x is going to equal sine inverse of 15 sine of 110 divided by 20. And then you would just type it into your calculator. Everybody understand? Yes? So you're going to watch really carefully if given one angle and two sides, where one of the sides is across from the given angle, check for how many triangles exist. Because wouldn't it be a shame to miss that when you know what to do, you just forget, you know? Because we're not going to say on the test, check to see if there are two triangles here, wink, wink. Like, we're not going to say that. We're just going to say solve the triangle. And if you don't catch that, you miss half the problem. So just be really careful. If you need to make note of that, do. All right. So just making sure, we don't have to do these. I just wanted to make sure if any of you need to go over seeing quickly how many triangles exist, we can. I have a couple examples. So look, notice I'm given an angle and two sides, angle and two sides, angle and two sides. And then notice all of those angles have a side across from it. Look, angle B, side B. Next example, angle A, side A. Next example, angle B, side B. So we would check here how many triangles exist. Do we need to go over that, or do you guys feel pretty confident based on your homework abilities that you understand how many triangles exist? Because we can go over it, but we don't have to. I'm asking you. What do you want? Okay, I'm hearing most people want to. Okay, let's go quick. So everybody grab a calculator. So watch, anytime I'm given some information and you'd say, well, this is that one situation I got to check, I would draw a quick picture. So angle is 25 degrees, side across from it is 4, and then the other side given is 6.2. Let's see how many triangles exist. Now, just a reminder, the first thing you're going to have to figure out real quick, if this side, if the swinging side is shorter than this side, we've got to hurry and figure out how long our height is, right, everyone? So you'd set up a right triangle statement, opposite over hypotenuse. So everybody, sine of 25 is equal to x over 6.2. So really quick, tell me what x is. You times up by 6.2. Okay. 2.6. All right, so it's obviously much longer, everyone, this 4 is obviously drooping down here, clear down here past this, correct? But at the same time, it's shorter than 6.2. So it's going to swing like over here, correct? So picture it swinging through. How many times is it going to touch?
3.
Twice. Don't think that this is a triangle, sorry. Like that confuses people, but it's overlapping, right? This would be like hanging over extra, does that make sense? So this one would have 2 triangles. So then remember, you would draw in, here's my first one is my, like a cute looking one. So then you would go like this, 25, you'd go 4, you'd go 6.2. Now this triangle right here is my obtuse looking one. So I would draw it like this. Still the stuff goes in the same place, 25, 6.2, 4. And then wouldn't we just solve using the law of sines? Now remember, well, the first thing we're going to find is this angle right down here using the law of sines. So then I would automatically be able to go over to triangle number 2 and find this angle. Because what would I do? 180 minus this angle, right, everybody? And then you could just solve them individually. The rest you'll just solve individually. Are we good with that? The hardest part is figuring out how many triangles exist. We won't finish that one off. But does that make sense? Okay, how many triangles exist here? So 75. The side across from it's 50, 1.2. The other side is 33.7. We don't even have to find the height on this one. If you catch it very quickly, isn't this, the swinging side, much longer? Yeah. So it's like clear, it's only going to touch one time, right? It's swinging way past it. 51 is much longer than 33, so there's only one triangle. So then you would just draw, finish this bad boy off, fill in the rest. Okay, next one, how many triangles exist here? Not drawing to scale, obviously, so we would have 150. The side across from it is 3. This side is 10. Now we got to check our height real quick because is it able to come down here and touch? What's going on? So let's hurry and find our height. Opposite over hypotenuse. So sine of 150 is equal to x over 10. So what is my height? 5. Okay, think about it, guys. 3 is shorter than 5. Will it ever be able to touch? No. So no triangle exists. So that'd be nice on the test because then you don't have to solve it. But you could. People do. You can keep solving and you're just going to get it wrong. Make sense? Cool. Awesome. If you don't understand the swinging thing, you can come in and I can help you one-on-one understand it a different way. I've just found in the past that this tends to be like visually easier to understand. But if you don't get the swinging thing, come talk to me. I can give you some one-on-one help how to think of it a different way. All right, let's go on to today's lesson, which is actually pretty straightforward and short. So if you cannot use the law of sines, we would use the law of cosines. So here are the times you will use the law of cosines. Now, I don't ever have to memorize when I use the law of cosines because I just know on the test, if I can't set up a true statement with the law of sines, then I use the law of cosines. So guys, if you're given 3 sides and no angles, there would be 2 unknowns in your true statement for the law of sines. Therefore, you could not use the law of sines. So this is a time when we use the law of cosines. You will also use the law of cosines if you are given 2 sides and an angle where the angle is not across from a given side. Because remember, that's the time we have to check for how many triangles exist. In this case, notice we have a side, and an angle in between the 2 sides. So we would have 2 unknowns in the law of sines. Like we don't know this side and we don't know this angle. So our true statement wouldn't work for law of sines. Do you guys see what I'm saying? All right, so we would use the law of cosines here. So right here is what I would write down. Here is the law of cosines formula. This is what I've made into a general formula because these are just 3 variations of the same formula. So write this down and I'm just going to point out some key features because it's actually decently easy to memorize if you notice some key things about these formulas. So I'm going to let you write it down and then I'm going to point some stuff out. All right, so I just want to point out, let's just look at this general formula here. This says a squared is equal to b squared plus c squared minus 2 times b times c times cosine of angle A. Do you guys notice how side A and cosine of angle A match up? They go hand in hand. That will always happen. See, look. B squared and cosine of angle B. C squared and cosine of angle B. So that's why I have these highlighted because the outskirts of town will always match up. That'll be the side and the angle across from that side always. Always. That's one thing to note. Now, to me, I noticed also a pattern here. Notice in this, it says b squared plus c squared. minus 2, and then it's always times b times c. So it's always minus 2 times that times that. See, look. A squared plus c squared minus 2 times that times that. See, minus 2 times that times that. So just, you're going to hear me say that a lot. You guys kind of see the pattern? Yes.
So if you're given the three sides,
Yep.
what do you have to solve for the angles of all of them?
Yeah, you would just find one angle to start out with, and then after that, we'll just use the law of sines to finish it off. All right, so let's go to our first example, which is given three sides, let's find an angle. Now, this is important. Now, a lot of people look at this and say, well, I could find any angle, which is technically true, but here's the catch. Because we end up taking a cosine inverse, our outputs for cosine inverse are between 0 and pi, if you can recall. So just remember this, guys. You always have to solve for the largest angle first. That is really important, okay? Just remember that. So obviously the largest side is 19, isn't it? So the side across from that would be the largest angle. So the first angle we're going to find is angle B. Now remember, that means in our formula we're going to have this. In the end, it's going to be cosine of angle B. So the side across from that has to match up on the outskirts of town. So right here, the side I'm going to put out here is 19 squared. Because remember in my formula I told you these will always match up. So then we'll just go for it. Then equals the other side squared, so 8 squared plus 14 squared minus 2 times 8 times 14. Times by cosine of angle B. Now from here I want everybody to grab a calculator and watch. The algebra is really easy if you don't make this one mistake that is made quite a few times actually though. So I want this one time for us to show our work. So guys, 19 squared is 361. So we have this. 361 is equal to, now question for you, can I add up these two things? Can I add up 8 squared plus 14 squared? Yeah. Yes, right? Well, there's no algebraic statement saying I can't combine those. Agreed? So I'm going to add those up and I get 260. Now here's what we have to be careful of. This is a minus sign. So we have minus, and then I am going to type in 2 times 8 times 14. 2 times 8 times 14. Which is 224. So we have minus 224, then cosine of angle B. Now what people do, listen to the mistake, is they algebraically then combine 260 minus 224, which is yikes. Okay, good. I'm glad that a lot of your faces were like, please don't do that. All right, because this is a time sign, right? So we're trying to get B alone here, so wouldn't we just subtract 260 now? Okay, so we have 101 is equal to negative 224 cosine of angle B. So then from here, when I divide now, divide by negative 224. And then from there, we have now this, cosine of angle B is equal to 101 over negative 224. To get angle B alone, what would I do? Good, inverse cosine both sides. So our final answer is angle B is equal to cosine inverse of 101 divided by negative 224. And then one thing to note, you can round your final answer. So it's right here, my angle, I'm going to change to pink, is 116.8. But when we go now to solve the rest of it, if we've got it maybe to be as accurate as possible. If you want your answers to match up with the back of the book, they put down the entire decimal in their next calculations. They don't round till the very end. Does that make sense? So now let's finish solving. Now, you could use the law of cosines again, but guys, that's way harder. Law of sines is quick, fast, and efficient. So now instead of finishing solving by law of cosines, we have enough information to solve by law of sines. So now let's set up another true statement and find another angle. Now, this time it doesn't matter. The next angle we can find, it can be any of them. So want to find angle C, angle A, doesn't matter. Same thing, right? Same amount of work. If I find angle A versus C. So first hour we did C. So we'd say sine of angle C divided by the side across from that, divided by 14, is equal to sine of angle 116.8. Now right here, once again, because we're doing a calculation, we need to use the entire decimal. So it's 116.8009832 divided by the side across from that, which is 19. So then we know that C is going to be equal to, angle C is going to be equal to, we times up by 14, then take the sine inverse. So the algebra will be sine inverse of 14 sine of 116.8, 0.09832 divided by 19. Yeah, good point. We better make sure our calculator's in degree mode. So I got 41.1 degrees, and now our final angle will be easy. 180 minus 41.1 minus 116.8. So this would be then 22.1. And we found all the angles. Okay. So we just saw how to use the law of cosines when given 3 sides and no angles. We have to find the biggest angle, and then we set it up as such. So let's look at one where we're given 2 sides and 1 angle. So look, 2 sides and 1 angle, where the angle is not across from a given side. Now if it was, we'd have to check for the different cases, wouldn't we? But it's not. So we'd say, oh, we can't use the law of sines. Law of cosines only ever has 1 triangle. So it says find side A. So let's put our x right here. Now sides x is what we're trying to find. We're going to start with that. So we have x squared is equal to, then the other side squared, 15 squared, plus the other side squared, plus 10 squared, minus 2 times 15 times 10 times by cosine of the angle across from the missing side. So cosine of angle 115. Now the algebra in this one's even easier than last time. Now we're trying to get x alone. So wouldn't we just square root both sides? And then technically there's a plus or minus, and then in this context of the problem we would throw out a minus because it wouldn't make sense to have a negative side length. So x is equal to, everybody practice typing this in to make sure you can get it right. When you get done typing it in, you should check your answer, and I get 21.3. So now if they said find the missing angle, like solve the triangle, you'd set up a law of sines problem now, wouldn't you? To find these angles? Okay, cool. All right, let's look at a story problem real quick. It's pretty straightforward stuff. Does anyone have any questions on this one? Were we all able to get the correct calculation? Okay, moving on. All right. So a pitcher's mound on a women's softball field is 43 feet from the home plate. So notice I've drawn that. There's the pitcher and 43 feet directly to our home plate. And the distance between the bases is 60 feet. So each base from base to base is 60 feet. It says, how far is the, wow, I have a lot of typos in here. I need to fix that. How far is the pitcher's mound from the base? So we're trying to figure out the pitcher's mound to first base. Now when people see this, they'll a lot of times assume like the distance from here to here is the same as from here to here, but that's not necessarily true. Now, can anyone tell me why I was able to draw in a 45-degree angle here with confidence? Perfect. This is a square, right? And if a pitcher pitches directly down the middle, which is what their goal is, right? Then it would be at an exact perpendicular cut of that 90 degree, creating a 45-degree angle. So let's redraw what triangle we have now. We know from here to here we were told is 60, so 60. We know this is 45 degrees. And then we know from here to here was 43. Now it wants to know the pitcher's to first base is how long. So in this case we're given 2 sides and an angle where the angle's between the 2 sides. So this is a law of cosines one, isn't it? So we would say, okay, x squared is equal to 60 squared plus 43 squared minus 2 times 60 times 43 times by cosine of the angle across from the missing side, so cosine of 45, and then what would we do to solve for x? Square root. So everybody square root that, and let's see how far the pitcher is from first base. Something. So just let me know what you get. Yep, 42.4. So it's 42.4 feet. Pretty dang close to the same from the pitcher to the home plate. Very good. Okay, last one is with some trig bearings. Last example of law of cosines. So let's look at this one. It says, a ship travels 60 miles due east. So starting at point A, everybody, they've actually given us the picture in this one. So it says a ship travels 60 miles due east and then adjusts, what the heck, adjucts. I need to go back and fix this before I teach the next one. And then adjusts its course northward as shown below. So then notice it's adjusted and gone northward. It says after traveling 80 miles in that direction, the ship is 130 miles from its point of departure. It says describe the bearing from point B to point C. So anytime you're asked to tell a bearing from one place to another, I go to the starting bearing that they want us to be at. So that would be from B. So what I always draw in is my as perfect as possible, never eat soggy waffles. Now the bearing on the water is always north, then it's either north then eastward, right? Or north then westward usually, right everybody? So which angle, if I wanted to go from here to here, which angle? That one, right? Right here, this little guy? Agreed? Because then you'd say north this many degrees east. All right, well, we can't find just that angle right now, but could we find this angle? Yeah, we have a big triangle that's not right, but we have 3 sides, don't we? So let's find this angle right here. So what would be on the outskirts of town? 139 squared is equal to 60 squared plus 80 squared minus 2 times 60 times 80 times by 80 times by cosine of angle question mark. Okay, so everybody practice. You guys go through, make sure you can find angle question mark correctly. I'm not going to go over it. I'm just going to write down what question mark is. I'm going to do it right here on my own in my calculator. Whole degree. So if you don't get 166 degrees, let me come over and help you out. So if from here to here is 166 degrees, how can we figure out what just this part is? Subtract 90, because isn't this the amount we need to get rid of, everybody? So that's 76 degrees. Right here. So now our answer we would say, well, to get from point B to C, we're going to head in the northward and then turn at 76 degrees in the eastward direction. Awesome. Okay, that is our last example of the law of cosines because they're all straightforward. There's no checking for multiple triangles, and it's pretty straightforward algebra. You guys did really good with that. So the last thing I want you to do is write down this additional area formula. It's called Herons Formula for area if given 3 sides. So just a reminder, if we were given a triangle with an angle and 2 sides, we used the formula for area of a triangle as 1/2 times side 1 times side 2 times by sine of the angle in between those 2 sides. That's how you find area if given 2 sides and an angle in between. Now if we're just given 3 sides, here is a formula you could use. Now you actually could find, if you were given 3 sides and no angles, you could still find the area without this additional formula. So we'll talk about how you would do that. Alright, so this formula is the square root of s times s minus a times s minus b times s minus c, where s is a plus b plus c divided by 2. So we have a triangle with a 12, a 15, and a 9. So to find the area, we would first find s. So s is equal to 12 plus 15 plus 9. and that's all over 2, which comes out to be 18. So then our area is going to be equal to the square root of 18 times 18 minus 12 times 18 minus 15 times 18 minus 9. So we get 54, I think. Let's try typing it in. 54. Now let's talk about, like, a lot of people sometimes they don't want to have to remember so many formulas for the exam. So instead, this is how I've taught it in previous years. I haven't even taught this formula, and I just had students do this. So I said, okay, if you're given 3 sides, 12, 15, and 9, I have the area formula. Area is equal to 1/2 times side 1 times by side 2 times by sine of the angle in between those two sides. So I would say, okay, I need an angle. Now, if I'm given 3 sides and no angles, I know I need to find the largest angle first. Now, I could do that by the law of cosines, couldn't I? Now, once I find theta by the law of cosines, then I would just set up a true statement. Area is equal to 1/2 times side 1, which would be 9, times side 2, which would be 12, times by sine of whatever the angle is that you find, which would be this angle. So that would be another way of doing that same problem, and you would get 54 as well. It's just a different way of reaching 54. You kind of see what I'm saying? Okay. Cool. Then that is the end of the lesson. So the rest of the time is yours to work on the homework and ask for help and talk about your final grade with me and whatnot.